So this video will continue looking at Chapter 10, Triangle Trigonometry, and continuing with Section 10.1, Angles and Right Triangles. In this video specifically, we will be looking at special right triangles to find missing parts, and specifically we're going to look at a right triangle and how to use the Pythagorean theorem. So this may be a review, should be a review for most everybody. So again, we are looking at right triangles. Remember that a right triangle has a 90-degree angle in it, and so that's indicated with the 90-degree angles. And so all of these are going to have to be right triangles that we're working with in this section. So remember that's, and it seems like, oh, okay, well, it's just a right triangle, but the calculations that we will be working with don't necessarily work with triangles that are not right triangles. So that's what I think I really want to point out more than anything else. And then also, you might want to familiarize yourself with the standard position of trigonometric working trigonometric problems and ratios. It's going to help with the labeling. You don't have to turn it in this way, but just remember that the 90-degree angle is in the lower right, and the hypotenuse is the opposite, is the line opposite from the 90-degree angle, and it is put on the left-hand side, going up from left to right. And then you can label your sides, which are labeled down here, and the sides are with lowercase letters as either A or B. And I think this video, or this slide, says exactly what I was talking about, so you can go ahead and read this slide on your own. Again, the hypotenuse is opposite the 90-degree right angle that is to the lower right. So also remember that when we're talking about right triangles, that we can use the Pythagorean theorem, which hopefully everyone has this written down in their notes for the any upcoming test and final exam. And so this can be written as a squared plus b squared equals c squared, or c squared equals a squared plus b squared, or you can also write it by taking the square root out of c and being able to move that around so that you have a and b isolated. And so make sure that you're familiar with being able to use the Pythagorean theorem. And so as a review, let's go ahead and you can solve this problem, and stop the video and try this one on your own. Okay, so looking at this, one of the things that I want to do, and this is just for practice, you don't have to have done this, but I want to redraw this in the standard form. And so the standard form would put our 90-degree angle here, and this length, our shorter side, would be 15, and our longer side would be 36, which means that we are missing and looking for C, which is the hypotenuse. And so knowing that we have A and B, and these sides are interchangeable, this could be A and this could be B, or B and A, but in this case we'll go ahead and we're going to solve. C squared equals 15 squared plus 36 squared. And get our calculator out, and so 15 squared is 225, and 36 squared is 1,296, Adding those together gives us 1,521. And again, bringing c squared down, if we find the square root of both of those, and we see that c equals 39. And I don't believe that they had a unit on here, and so that would just make this hypotenuse 39. Okay. All right, let's go ahead and try another one, and you can try this one on your own again, and I even encourage you to try to put it into the standard form. Okay, so let's take a look at this then. We're going to redraw this so that our 90-degree angle is down here in the corner. And in this case, 9 is our shorter side, and 19 is our hypotenuse. So, knowing that, then now we are missing, and we'll call 9 will be A, and in this case, we'll call this longer side B. And so, knowing that, we can go ahead and use our formula here, and we have C, so 19 squared equals 9 squared plus B squared. And so let's just go ahead and calculate this out. And we're going to say 19 times 19 is 361. Equals 9 squared is 81 plus B squared. Now let's go ahead and isolate the variable. So we will subtract 81 from one side. What we do to one side, we have to do to the other. 361 minus 81 is 280. Equals B squared. And we want to be able to get the square root, or we want to get B by itself, so we need to square both sides. So the square root of 280 is 16.73 equals B. And so we'll go back and put this onto our problem over here. And so B is 16.73, whatever units that they had. Okay, that's just a little review of the Pythagorean theorem. We'll be using this more and expanding on this in future videos.